Resolution of vectors. The process of splitting of vectors is called resolutions of vector. The part obtained after resolution are known as component of given vector. Now look at here. For example, we are taking here a vector. This is a vector P represented with a line A, B. We can resolve this vector in two rectangular components. This way, this is in this direction, vertical direction, a component we can resolve, and we can resolve in this horizontal component. Look at here. This vector P can be resolved in this way, that is a horizontal component and the vertical component. How it is so? Because already we have learned in the law of parallelogram that the two vectors which we are taking in the two sides of a parallelogram, the resultant of this two vector can be represented by the diagonal. So we are just doing the opposite process of that. We are taking here a vector P in the diagonal and we are splitting it into the two components. That is one component that is in the horizontal direction. This component is called horizontal component, and here this component is called vertical component. It is called vertical component. Now whatever vector will be here, that means if this P is splitting into the two components, suppose this P is making with its horizontal component angle theta, then we can just draw here a line like this, a straight line, and here you can find now this is the line, the length of the line, this is equal to this line here. That means in magnitude wise these two are equal, and even these are parallel, so the direction also is equal. So whatever vector is represented here, that means the vertical component represented here, can be written here also. Okay, so we will just make a triangle with this, that is A, B, and I am just writing here this as C. That means what we did actually, we are just following the triangular rule for the addition of the vectors. So in that case you will find this is AC. Look at here. This is AC and CB. AC plus CB will give us P. That means the vector P is splitted in two components, and one component is represented here with the AC, another component is represented here with the CB. Okay, AC is called horizontal component of vector P and CB is called the vertical component of vector P. That means it can be AD. I am just writing here AD. So AD and CB are representing the same vector here because both are parallel and the lengthwise equal. That means magnitude and direction both are equal here. Okay. So this way now you will find here the vector P is, what happened? It is splitting in the two component, vertical and the horizontal component. Now what will be the value of the horizontal component here? The horizontal component, you can look here, this is equal to what? It is, if we are just following this triangle ABC, it is a right angle triangle here. So now you can see that BC is the perpendicular and AC is the, here what you will find, BC is the perpendicular, sorry, and this AB, I am writing here AB. The AB is the hypotenuse. So perpendicular upon hypotenuse is equal to sine theta. That means this BC is equal to what? It is equal to AB sine theta here, and AB is what here? AB is P sine theta. AB is P, so I am writing here P sine theta. Okay, now you will find that the BC is here vertical component. So this will come the vertical component. It is coming here. The vertical component is equal to the vector and the sine theta. Now, if we'll see the horizontal component, that means AC. So we can write AC upon AB. AC is what here? AC is base and AB is hypotenuse. So AC upon AB will give us cos theta. That means AC is equal to AB cos theta, and that means what you will find here? This is AC, this is P cos theta, and it is horizontal component. This one is the horizontal component. So we have splitted here. We have splitted vector P in two component, the horizontal component and the vertical component. The value of horizontal component is given by the P cos theta, and the vertical component is given by P sin theta, where theta is the angle with the horizontal component of the vector. So this is called resolution of vector, or we have resolved vector in two components, horizontal and vertical. A question is given here. A force is inclined at 60 degree to the horizontal. If horizontal component of force is 40 Newton, calculate the vertical component. What is given here? It is given here, this is a force and it is inclined with the horizontal component by 60 degree, and the horizontal component, that is F cos theta. We know that the horizontal component, which is F cos theta, is given here equal to 40 Newton. It is equal to 40 Newton. We have to calculate the vertical component. So look at here, it is given here F cos theta. That means the theta is what here? Theta is equal to 60 degree. This is the horizontal component. It is horizontal component and it is equal to F cos 60 degree equal to 40 Newton. That means the force. Now we are going to calculate the magnitude of force here. So cos 60 is what? It is equal to 1 upon 2, 40 Newton. So the force is equal to 40 into 2 here. That means it is equal to 80 Newton. Now we'll calculate the vertical component here. The vertical component is equal to F sin theta, and because F is 80 and sin theta is 60 degree here, so sin 60 is equal to root 3 upon 2. That means this is 40 root 3 Newton. So the vertical component is equal to 40 root 3 Newton. Okay.